convergent sequence are bounded. సో ఇప్పుడు మనం దీని యొక్క ప్రూఫ్ చూద్దాం. let s is equal to sequence Sn is a real number sequence and if it is convergence to S, if it is convergence to S, so that is మనం ఏం రాసుకోవచ్చు అంటే లిమిట్ సీక్వెన్స్ Sn is equal to S. So we have proved that the convergent the sequence S is equal to Sn is bounded. So our proof is the sequence Sn S is equal to Sn is bounded. So already the given is limit Sn is equal to S. Now limit of sequence by definition epsilon equal to 1, there exist n greater than n such that mod Sn minus S less than epsilon. So that is therefore Sn minus S less than 1. Why? Because we take epsilon is equal to 1. This is the equation 1. Let consider Sn equal to is the right of another form, that is the Sn minus S plus S. On that time we write less than or equal to Sn minus S plus S. So why? Because less than or equal to is triangle inequality. So on that time less than or equal to mod Sn minus S less than 1, that is 1 plus mod S from equation 1. So now we take m is equal to supremum of S1 comma mod S2 dash 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 S k plus 1 Sn. So that is a supremum of mod Sn less than or equal to m, where all n greater than n. So hence the sequence S is equal to Sn is bounded. So therefore convergent sequence are bounded. So this is the most important theorem in a sequence. మరొక most important theorem. A sequence is a convergent sequence if and only if is a cauchy sequence. సో ఇక్కడ మనకి ఎప్పుడైతే ఇఫ్ అండ్ ఓన్లీ ఇఫ్ వస్తుందో 2 టైప్స్ ఆఫ్ సొల్యూషన్ ఉంటుందండి, కేస్ 1 అలాగే కేస్ 2. ఫస్ట్ ఆఫ్ ఆల్ మనం ఇక్కడ తీసుకున్నట్లయితే ఫస్ట్ కండిషన్ సపోజ్ దట్ sequence S is equal to Sn is convergent. First condition. Now we prove that S is equal to Sn is a cauchy sequence. So this is the first condition. If and only means when you take the first condition, prove second, and reversely cauchy sequence are convergent. So first suppose that sequence S is equal to Sn is a convergent. On that time we prove that S is equal to Sn is cauchy sequence. So right, we know that sequence S is equal to Sn convergent to S. That means limit Sn is equal to S. By the definition of limit By the definition of limit epsilon greater than 0, there exists n greater than n such that mod Sn minus s less than epsilon by 2. This is the one. Similarly, limit Sm is equal to s. We write mod Sm minus s less than epsilon by 2. This is equation 2. Let we consider mod Sn minus Sm equal to mod Sn minus s plus s minus Sm. This form written as usual the another type Sn minus s plus or minus, so that is the positive negative cancel, and that time Sn minus Sm. So less than or equal to Sn minus s plus s minus Sm, less than or equal to mod Sn minus s plus negative or positive, no changes in the mod. That's why Sm minus s. So less than or equal to Sn minus s means less than epsilon by 2, and this is the epsilon by 2. So now we get 2 epsilon by 2 by less than or equal to epsilon. So mod Sn minus Sm, so less than epsilon. So therefore the sequence S is equal to Sn is Cauchy sequence. So that this time case 2, what we take, suppose sequence S is equal to Sn. By definition, every epsilon greater than 0, there exists n greater than m less than or equal to n such that mod Sn minus Sm less than epsilon by 2. This is the Cauchy sequence. Now if prove, we know that since S is equal to Sn is Cauchy sequence, but we prove that Sn is the sequence, Sn is a convergent. So we know that every Cauchy sequence is bounded. Every Cauchy sequence is bounded. Then sequence S is equal to Sn is bounded. So by the Bolzano theorem, Bolzano-Weierstrass theorem, we know that every bounded sequence has a convergent sequence. Then the sequence S is equal to Sn convergent. That is subsequence S dash is equal to Snk. So subsequence S dash is equal to Snk convergence to S star. So on that time limit Snk is equal to S star by the definition of limit epsilon greater than 0, there exists n greater than n such that Snk minus S star less than epsilon by 2, where nk is equal to k. On that time Sk minus S star is equal less than epsilon by 2. This is the equation 2. Since n comma m greater than n, take n is equal to m is equal to k in equation 1. So we get Sn Sk less than epsilon by 2 where n comma k greater than n. To show that limit Sn is equal to S star. Now consider mod Sn minus S star equal to Sn minus S star plus Sk minus Sk. This is the another type, plus 1 and negative. So less than or equal to Sn minus Sk plus Sk minus S star. This is the epsilon by 2. This is epsilon by 2. We get epsilon. So mod Sn minus S star is less than or equal to epsilon. That is, therefore, Sn convergence to S star. So therefore, every cauchy sequence is convergent. This is the case 2, and from case 1, case 2, hence we proved our theorem. ఓకే ఫ్రెండ్స్, ఇటువంటి సింప్లికేషన్ షార్టెస్ట్లో మీకు అన్ని సీక్వెన్స్ సిరీస్ ప్రూఫ్స్ అందియబోతున్నాను. ఈ వీడియో కనుక మీకు నచ్చినట్లయితే షేర్ చేయండి, సబ్స్క్రైబ్ చేయించండి. ప్లీజ్ సపోర్ట్ మీ.